Hey Jaden, sorry, I was sending an email real quick. So you gotta be specific. Is this what assignment? I read that it was the 2017. I wasn't sure if you meant to say 2017 or if you meant the 18. So clarify which assignment this was. Yes, 2017. Okay, so 4D, yeah, you have to use L'Hopital's. First, you have to show that it's indeterminate because you get a fraction of 0 out of 0 when you direct sub, and then you use L'Hopital's rule. So if you need me to go over that, let me know. Andrew, 1C and 1D of 2018. Okay, so I'm going to do the 2018 one then. Andrew, by the way, I just sent you an email about your Wi-Fi. Go ahead and read that. Basically, I just said that's fine. You can submit work to me later, if need be. Just make sure, Andrew, that you let me know if you submit anything late and I already graded it. I won't go back to check, so you have to just email me to tell me that you did it late. All right, 2018. FRQ, Andrew, you said 1C and 1D. Let me open up the assignment, get this rolling. Okay. So, Andrew, they give us time and they give us G of T, which represents cubic feet per minute. They give us this table. Okay, and there's a bunch of information. You read that. C says the grain in the silo is spoiling at a rate modeled by W of T equals 32 times the square root of sine pi t divided by 74. Okay, so that's the rate at which the grain is spoiling. G of t was the rate at which grain was being added. So it had nothing to do with the spoiling. It's just grain being added. So C, they introduced this new idea of spoiled grain. Which makes sense, because if you're storing grain, after a while it can spoil. And if it's spoiling, then they're going to have some issues. Yes, Jaden, it's -8. Correct. Well done, well done. Okay, so yeah, we have this formula that's given to us. It says, using the result from part B. Okay, so it's important you got part B right. So before I even go, Andrew, tell me what you get for part B. Hey, Alexis, no, you don't have to do number 5. Just 1, 2, 3, 4, and 6. Number 5, you are free for that. That you haven't learned that yet. Okay, good. So yeah, Andrew, 160.8 feet cubed. So you're on the right track. All right, so we're using that result that you just wrote there to approximate the amount of unspoiled grain remaining. Okay, so we know that grain is spoiling at this rate. We want to figure out the amount of unspoiled. Okay, well, in order to get the amount of unspoiled grain, we need to first know the amount of spoiled grain. So if this is the rate at which grain is spoiling, to find the amount of the grain spoiled, we take the integral from the time interval 0 to 8 of that function. All right, and you'll throw that in your calculator. Hopefully you're okay with that. If you need to learn how to do that in your calculator, obviously let me know. And when you do that, you end up getting 99.051497. and this is the amount of spoiled grain. You're welcome, Alexis. So, Andrew, once you get here, okay, so we have the amount of spoiled grain. If we want to figure out the amount of unspoiled, that's going to be equal to the total amount of grain minus the amount spoiled, right? So we get this equation. Now we just got to fill in the parts. We, in part B, approximated the total amount of grain. So the total is going to be equal to 160.8. The spoiled we just found was 99.051497. Subtract those, and you get approximately 61.749 feet cubed. So that's my approximation of the unspoiled grain. No, Andrew, you don't need to. So the only time, Andrew, we do that is when we're taking the integral of a derivative. But if we're ever given a function and we have a calculator, if we're solving an integral, then just do that. Just plug it into your calculator. You don't need to use any sort of algebra or fundamental theorem or calculus, nothing. Just throw it in your calculator. If it said the integral from 0 to 8 of w prime of t, and we didn't know what w prime of t was for some reason, then yes, you would have used w8 minus w0. Is that making sense, Andrew? So I guess take a look back at the fundamental theorem of calculus. It states that it's the derivative, integral of a derivative. That's the key. In this case, the WT, it does represent a derivative because it's a rate of change, but we actually know what the function is, so we can just throw it into the integral. All right, so that's 1C. Okay, hopefully that's okay. So let's look at D now. D says, based on the model in part C, so based off what we just did in part C, is the amount of unspoiled grain in the silo increasing or decreasing at t equals 6? Okay. So, increasing or decreasing at 6. This is what we have to figure out then. We have to figure out the different rates of spoiled compared to unspoiled. So we know that G of t, in this case G of 6, is going to be the rate at which grain is being added. So the rate at which, and you find that, you can look at the table. So we just look at the table, it's 18.3. So that's the rate being added. Now the amount, or the rate at which the grain is spoiling can be found by the W, the formula for W. W of 6 is equal to 16.063. That's the rate grain is spoiling. Okay, so we have some of these important pieces. So based on the model, is the amount of unspoiled grain in the silo increasing or decreasing? We know that the rate of it being added, and we know the rate at which the graph is, or the grain is spoiling. So to see if the amount of unspoiled grain, basically we're just got to figure out this kind of comparison. Is there more going in than being spoiled? Because if there's more grain being added than that is being spoiled, the amount of unspoiled grain is going to be decreasing. So we have to kind of look at this ratio. So we take these two, and we say, okay, what's the difference? So we subtract. What's G of 6 minus W of 6? We got to figure out at times 6, the rates of it entering and spoiling, which one's bigger? Okay, in this case, you'll find that this ends up being about 2.24. And 2.24 is greater than 0, right? That's a positive number. So then that means if we get a positive number for our difference of our derivatives, and that's going to mean that the unspoiled soil is increasing. I'm going to say the actual question said the amount. So amount unspoiled soil is increasing. Right? If we want to check if the amount is increasing or decreasing, we take the derivative. The derivatives are given by w of x, or the derivative of spoiled is given by w6. The total is g of 6. So to find unspoiled, you take their difference. So Andrew, go ahead. Let me know if you need any more clarification. If that was good, need me to walk through any more, let me know. Alexis, for the AP test, we use our calculators for integrals, derivatives, and antiderivatives. Do we need to still show the work, or do we just need the answer and put that we use the calculator? Yeah, that's it, Alexis. So you have to do sufficient enough work to show that you got to the point where you can plug. So like your paper should read exactly what you're going to plug into your calculator. So any pieces, any variables, anything that needs to be replaced should be replaced. It should have bounds, like that should be on your piece of paper. The actual evaluating part, you just said use calculator and then put your answer, what it equals. Hopefully that was clear. Yeah, that makes sense. I just took the derivative of w to find increase or decrease. That makes a lot more sense. Yeah, so the big thing with this, Andrew, is there's 3 variables, right? W spoiled, G is total, and then unspoiled is kind of its own thing, whatever you want to label it. To find unspoiled, you need to take the total minus the spoiled. So if you're taking a derivative, it'd be the derivative of the total minus the derivative of the spoiled, would give you the derivative of the unspoiled. That's kind of how I look at it. I probably should have wrote that down, but maybe that helps also. Jaden says 3C, 3D. Jaden, you gotta be specific, my man. Are we talking 2018? Which one are we working on here? Oh, 2017. All right. 2017, 3C and 3. Okay, that's the one I think you emailed me about, right? Give me a second. Let me open that assignment up. Hopefully it doesn't take too long. Okay. 2017. You have a good day, Jaden? Have a good weekend? Missing baseball? How you feeling? So far I am. All right, good to hear, Jaden. Andrew, it's in the calendar. It is skip C. So question 2C. Skip that. Okay, Jaden, you want to do 3C and 3D. All right, so this should have been what you're doing here, Jaden. All right, the graph of the function. So we're given this graph. We're given what g of x equals to, and we're going to have to solve some questions. All right. So let's look at 3C. Have a great day, Andrew. So it says, find all the x values in the interval -5 to 5 at which g has a critical point. Classify each critical point as the location of a minimum, maximum, or... Oh, wait, sorry. Reading the wrong one. That was D. We'll get to that. All right, C was on what open intervals, if any, is the graph of G concave down? So, Jaden, whenever you see the word concave, always think second derivative. Always think second derivative. So if we're trying to find an interval where the graph is concave up, we want to figure out then when is G double prime of X greater than 0. That's the question we want to answer. Well, we know that G, I think by this point in the problem, you should know this fact. Right? If G of X equals that integral, then G prime of X equals F of X, which means G double prime of X equals F prime of X. So really what we're trying to figure out is this question. Not only these are the same thing, so these two are the exact same statements. G double prime of X is greater than 0, that means that F prime of X is greater than 0. That's what we're looking for. Mine says concave up. I don't know if... Yeah, I'll show you my question. My question says concave up. See, it says what open intervals of any is the graph of G concave up. Maybe you misread it. Unless my assignment says something different. That'd stink. Oh, okay. No. Concave up. Yeah, the question asks for concave up. So it's greater than 0. And to find this, all we got to do is look at the graph. So let me I have this up, I might as well show you now. We want to look at the graph of F. If F prime is greater than 0, what has to be true? Well, that's all the spots where there's a positive tangent line. So like right here, these are all positive slopes, positive slopes, positive slopes, bam. So that's one of my intervals, which is -5 to -2. And then I go concave down that whole way because these are all negative slopes. And then I'm back to positive slope. So from 0 up until, what is that, 3? Yep. I'm again a positive slope. F prime is positive, greater than 0, so that's concave up. And then it's nothing here. Their slope is 0. So your final answer then is -5 to -2 and 0 to 3. That's where my graph is concave up. AP test is coming up, Jaden. Coming up fast and furious. All right, you said you also wanted to look at 3D. Sure thing. Now, 3D says find all x values in the interval -5 to 5 at which G has a critical point. Classify each critical point as whatever it is. Okay. We think of critical points. That means we have to think of a first derivative. Whenever you see minimums, maximums, critical points, you got to be thinking first derivative. So if I have G of X and I want to figure out critical points, I need to set it equal to 0. So when does G prime of X equal 0? Another way to say that is when does F of X equal 0? Right? Because F of X equals 0 is the same thing as G prime of X equals 0. Because G prime of X equals F of X. So we just look at the graph and see where it crosses the x-axis. This happens at x equals -2 and x equals 1. Whenever we see relative, the word local or relative, we always want to think about sign chart. Candidate's test or sign chart. Well, no, sorry, not candidate's test. Let me rephrase. It's always sign chart. Candidate's test is used when you see absolute minimum or maximum. This is local or relative minimum or maximum, so we got to think sign chart. So what I want to do is I want to make a sign chart so I can observe, it'll tell me what's the behavior of this graph at each of these points or each of these intervals. So I need to see what's going on with G prime of X, aka F of X. So between -5 and -2, is f of x positive or negative? It's negative. Between -2 and 1, is f of x positive or negative? Looking at the graph again, it's negative. And when I say it, I mean the y values are all negative. Look at x from 1 to 5. Is f of x above the x-axis or below? Are the y values positive or negative? They're positive. So I put a plus. So your final answer, this is super important, and people lost points, and I think you were one of them who lost points on this. When I write my answer, this isn't enough. A sign chart isn't enough. I have to state at x equals blank, so in this case at x equals 2, neither min or max, because the sign does not change. So there is not a relative min or a relative max at x equals -2. Because look, from -5 to -2, it's negative, and then it stays negative. We only have a minimum or maximum when the slope changes from positive to negative or negative to positive. If the sign doesn't change, you don't have a min or max. At x equals 1, local minimum occurs. Because sign changes from negative to positive. So this is a 100% full credit answer. If you just do the sign chart and just put your answer, you're not going to get full credit. You'll miss a point every time. You have to say at x equals 2 because it doesn't change sign, and at x equals 1 there's a local minimum because the sign changes from decreasing to increasing, or minus to plus, or negative to positive, right? So super, super important you include that. Yeah, no problem, Jaden. Let me know if you have more questions. Hey, Jaden, also, if you get the chance, let Nick know that he asked me if he could still submit some assignments. He never submitted them. So if you think about it, text him and be like, hey, Mr. Harris is looking for some of those some of that late work. You have a great day too, Jaden. Thank you. He's watching stream. Hey, Nick. Why are you being so shy, Nick? Why don't you ever comment? You could be like, hey, Mr. Harris, how's your day going? You having a good day? Come on. It's like we're strangers, Nick. It's like we've never talked before. Why gotta be so shy? My pictures won't submit on College Board. Jada, make sure they're saved in like the right format. So there's only a couple formats you can use. So double check it's like JPEG or PDF or something like that. Maybe try accessing on your phone. Doing it that way. I'm not sure. I don't know like why they won't. If you have like a error message, let me know what it is or something. It is JPEG and says they're just loading. Oh, I mean, okay. Maybe it's a Wi-Fi issue. Maybe just like log out some of the tabs or log out of my stream or something. I've always been submitting them on my phone because it's easier to take pictures. Yeah. Excuse me. Yeah, I don't know exactly. I know that it's nothing to do. Like, there's nothing I can really help with. Unfortunately, that's how the situation is. I think it's all about just College Board and your Wi-Fi. So if you have a lot of things loading up, it might just take a while. College Board can be kind of annoying at times, to be honest. So, thank you, Jaden. Yeah, I don't know. I wish I could help you out with it. I don't really know exactly why sometimes it takes a little long to load them up. Unless you like got like a unless College Board fixed their site to be more productive and your Wi-Fi was like best of the best. I don't really know what other solution there is. Okay, cool. So maybe that's a good advice. Just refresh it. Now, on the AP test, you don't want to refresh the page at all. Never refresh the page. That's what I was told. I think if you do, like, it's salvageable, but you have to like, click on the link again to get back into your test, which wastes time. So to make sure you're not doing that. Cool. See you, Jaden. Have a good day. Emma, can you help with 1C and 1D, the homework? Yeah, sure thing. Okay, let me open up the question. So this is going to be the 2018 FRQ. Okay. So they give us this table. It's about. Oh, okay. I actually already went over this. Hold on. Let me see. All right, Haber. I'm gonna try this just so I don't have to write everything over again. I'm gonna walk through. This is all the work for it. So I'm gonna walk through the thought process. Okay. So first of all, what's really important is, Emma, what did you get for B, 1B? What did you get for 1B? $160.8. Okay, perfect. All right, so that's number one. That's really important because the question says, it says the grain in the silo is spoiling at a rate modeled by W of T. Using the result from part B, so using that 160.8, approximate the amount of unspoiled grain remaining in the silo. So here's my paper. I just wrote WT again. That's given to you. You don't need to write that out. W of T represents the spoiled, the rate at which grain is spoiling. So, you keep grain into like a silo, right? Some of it is good, some of it turns bad. So WT represents the bad grain, the spoiled grain. So basically what we have is we want to figure out if that's the rate at which grain is spoiling, we want to know what's the amount of spoiled grain. Like how much of the grain in our silo is spoiled. And to find that, you take the integral of the rate. So the integral from 0 to 8 of our rate of change of spoiled grain, which is W of T, and you throw that in your calculator. So throw that in your calculator, and you'll find your answer is 99.051, whatever, 497. That represents, as I wrote up here, the amount of spoiled grain. Not the rate of change, the amount of spoiled grain. Okay, so that's the first step. Super important. Now, at the end of the day, the question wants us to know, approximate the amount of unspoiled grain. Well, unspoiled grain is equal to the total amount of grain in general, just how much grain is there, spoiled and unspoiled together, minus the spoiled. So your total minus your spoiled gives you the amount of unspoiled. So we have this equation here. Well, we know the total we just got in the part B. Part B we found it was 160.8. That's our estimate for the total amount of grain. So you take that total minus the amount we just found was spoiled, which is 99 point whatever. Subtract those, and that's where you get the 61.749 feet cubed. So I'm going to stop there and chat. Let me know if you're good with that, Emma. Cool. All right. So let's go to part D then. Part D says based on the model of part C. So we're using this idea here. This kind of model, the fact that unspoiled is equal to total minus spoiled. We're using that idea to find this question. Is the answer to this question. Is the amount of unspoiled grain in the silo increasing or decreasing? So let's break this down, Emma. This is just the total amount. We want to know, is the amount increasing or decreasing? Whenever we're trying to find if something is increasing or decreasing, we take a derivative. So basically, what we're doing for 1D, I'm just going to write it down here, is we're saying unspoiled prime No, this isn't like very, you haven't seen this connotation. This is just a concept. You don't have to write this down. But essentially what we're doing is if we need to find increasing or decreasing of unspoiled grain, we need to take the derivative of that. Well, if I'm taking the derivative of the left side, I have to do it to the right side. So I need to take the derivative of the total. But we have a function that represents the total. That function is g of t. So in other words, the derivative would be g prime of t. We also have a function to represent the spoiled. So that would be represented as w prime of t. So this is going to be like our new general outline for this problem. And when I was telling Andrew this, I was going over this with Andrew. I probably should have mentioned that first. So I'm mentioning it first to you. I told him like towards the end that was the way to look at it. But I kind of like looking at it that way. So essentially what we need in order to get what we're looking for, the unspoiled, is that positive or negative. We need to find what g prime of 6 is and w prime of 6. Because the question asks specifically at t equals 6. So I found g of 6 by just looking at the table. You get 18.3. I find w of 6 by plugging into my calculator because I have an equation for w, and I get 160.63. Or sorry, 16.063. Put that into my equation, subtract them, and you get 2.24. Uh, 2.24 is greater than 0, which means that the amount of unspoiled soil is increasing. Was there a part of question? Yeah, so if you look in the calendar, skip C. So 2C you can skip. Yeah, no problem here. Have a great day. Oh, wait, hey, bro, are you still here, actually? Type in the chat if you didn't leave yet. I want to clear something up, because I just realized I think my notation was wrong.